Hello everyone, I am Dr. Mohit. In previous videos, we discussed why we need epsilon delta definition of a limit of a function and what this definition actually means. In this video, I will explain how to show or how to prove limit of a function f of x is L as x approaches to x naught using epsilon delta definition. Let's take an example. Show that limit of the function 5x minus 2 is 3 as x tends to 1 using epsilon delta definition. Here function is 5x minus 2, x naught is 1 and limit value is 3. To show the given limit, for any epsilon greater than 0, we have to find corresponding delta greater than 0 such that whenever x lies within delta distance from 1, function values f of x lies within epsilon distance from 3. This delta inequality implies that x lies between 1 minus delta to 1 plus delta and x is not equal to 1. This epsilon inequality implies that function values are between 3 minus epsilon to 3 plus epsilon. Okay. See the graph also. For some epsilon, function values are inside vertical range which is symmetric about L equal to 3 and it is from 3 minus epsilon to 3 plus epsilon. That is function values are epsilon distance above and epsilon distance below from L equal to 3. Now our aim to find the delta for this epsilon. How to find? We find delta by working backward from this epsilon inequality. So solving this epsilon inequality, putting the value of function f of x, which is 5x minus 2. 5x minus 2 minus 3 means we are getting 5x minus 5 modulus 5x minus 5 less than epsilon. This implies 5 mod x minus 1 less than epsilon. Divide both sides by 5, we get modulus x minus 1 less than epsilon by 5. If we choose delta equal to epsilon by 5 or any smaller positive number, that is, we can choose delta as equal to epsilon by 5 or less than epsilon by 5, then this condition will be satisfied. Means this delta inequality for delta equal to epsilon by 5 implies this epsilon inequality, which proves the limit definition. Look at the graph. For this epsilon band of function values from 3 minus epsilon to 3 plus epsilon, we are getting symmetric delta band which is from 1 minus delta to 1 plus delta, where delta is less than epsilon by 5 or equal to epsilon by 5. In this graph, delta is epsilon by 5 as you see the function value at 1 minus delta is 3 minus epsilon and f of 1 plus delta is 3 plus epsilon. From this you can find out the value of delta, which is epsilon by 5. So we can say for these values of x between 1 minus epsilon by 5 to 1 plus epsilon by 5, function values are inside the vertical yellow band. Okay, so function values are between 3 minus epsilon to 3 plus epsilon for all these values of x. Also, when delta is a smaller positive value, say here in this graph, delta is epsilon by 10, means less than epsilon by 5. So you can see that for these values of x, function values are still inside vertical band. Okay, function values are still inside vertical band. Okay, so we can say for epsilon equal to for delta equal to epsilon by 5 or any smaller positive number, means less than epsilon by 5, keeping x within symmetric band will keep the function values within epsilon band. This proves the definition of limit. Let's discuss another example. Prove that limit of the function 9 minus x is 5 as x tends to 4 using epsilon delta definition. To prove the limit, by limit definition, for any epsilon greater than 0, we need to find the corresponding delta. For that, we start with solving the epsilon inequality as earlier. So, modulus of f of x minus L less than epsilon, function is 9 minus x and L is 5. So, we are getting modulus of minus x plus 4 less than epsilon. This implies modulus of x minus 4 less than epsilon. Therefore, for each epsilon greater than 0, if we choose delta is epsilon or any smaller positive number, that is delta is less than or equal to epsilon, then this delta inequality for delta equal to epsilon implies this epsilon inequality. That proves the limit definition. So for some epsilon, this inequality implies that function values lies between 5 minus epsilon and 5 plus epsilon. Look at the graph also. Okay. So to prove the limit for this vertical symmetric band for function values from 5 minus epsilon to 5 plus epsilon, we find a symmetric delta band for x values from 4 minus delta to 4 plus delta, such that for all these values of x within this delta band, function values lies within this epsilon band. In this graph, delta is epsilon, and this you can see from here as function value f of 4 minus delta is 5 plus epsilon and f of 4 plus delta is 5 minus epsilon. So from here you can see that delta is epsilon here. So for this delta equal to epsilon, See here, for these values of x, function values are within this yellow vertical band. Okay, if we choose delta equal to epsilon by 2 means smaller than epsilon, then also you see here for these x values within this delta band, function values are inside this epsilon band. You can see here. Okay, the function values are inside this vertical band. Hence, we can say for delta equal to epsilon or any smaller positive value, say epsilon by 2 or any other smaller value, keeping x within delta band will keep the function values within epsilon band, which proves the definition of limit. Okay, so in this video I explained that how to prove limit of a function. Please note that proving limit definition means finding corresponding delta for each epsilon, because delta depends on epsilon. In next video, I will explain how to find delta for some given epsilon. If you found this video helpful, please like, comment to the video, subscribe to my channel and share. Thanks for watching. See you in the next one.